Hello guys, welcome to today's lesson. My name is Sihle.Enjoy. Today we'll be looking at exponents. So before we get to solve the sums, we'll just have to recap on the laws of exponents. For law 1, which states that whenever you're multiplying things of the same base, you'll have to add your exponents. Looking at this demonstration, we have an a to the m times a to the n being equals to an a, then the exponents were being added, which is m times n. So the law is simple. Whenever we are multiplying things of the same base, you'll take one base, then you add the exponents. For example, we'll take 2 to the 2 times 2 to the 1, which this will give us, we'll take one base, which is a 2, then we add the exponents, 2 plus a 1, of which this gives us a 2 to the 3, which this is an 8. So, law 1, it's as simple as we are seeing it now, that whenever you're multiplying things of the same base, you'll have to add the exponents. Then now, we'll go on to revise law 2. Law 2 states that dividing things of the same base, you'll have to subtract the exponents. So looking at our demonstration, we have an a to the m divided by a to the n. So we take one base, then we subtract the exponents, which an a to the m divided by a to the n gives us an a to the m minus n. For example, if you were to have a 3 to the 3 divided by a 3 to the 2, we are having the same base, which is a 3. We'll take the base, then subtract our exponents, which this will give us a 3 to the 1. That's our second law. Then we go for our third law, which states that whenever we are having a product of things inside a bracket, then we have these outside the bracket, this exponent n. The exponent n is for both what's inside the bracket, of which this will give us an a. We know that our a is to the exponent 1, as much as our b as well is to the exponent 1. So it's our a, 1 times n, times a b, 1 times n, which this gives us is a to the n, b to the n. That's our third law. For example, if we are to go for an x to the 2, y to the 3, close bracket to the 2, we are to apply this law, which this 2 is going to multiply both the exponent. So it's x to the 2 times a 2 multiplied by our y to the 3 times a 2, of which this gives us an x, 2 times 2, it's a 4, y, 3 times 2, it's a 6. That's our third law. Then we go on to our fourth law, which states that if you were to have an a over b to the m, this m is for both the exponents of a and b, of which this a is to the 1 as much as this b is to the 1. So this will give us an a 1 times m all over a b 1 times m, of which this will equal to an a to the m all over b to the m. That's our fourth law. We are now going for our fifth law. Oh, before we go to our fifth law, let's just give an example for this one, where we are having an x to the 2 all over 3 to the 4 to the exponent 3. This will give us an x 2 times 3 all over a 3 4 times 3. Then this will equals to an x 2 times 3 is a 6, 3 4 times 3 is a 12, yeah, let's not simplify it further. So this law states that if you have this fraction, which is a over b to the this exponent will multiply both the exponents of the numerator and the denominator, which are in bracket. Then we go for our fifth law, which is a to the m close bracket n. These exponents will multiply, which is a m times n, which this is a m n. We'll just take one example as well, where we'll have a 2 to the, let's go for a 2x close bracket 3. We still take the same base, then we multiply these two exponents. This will be a 2x times a 3, of which this will give us a 2 to the 6x. Yeah, then now we'll just go for the last law, which is everything to the 0 is equals to a 1. So if I were to have an x to the 0, this is a 1 as an example. Also, if I were to have a 9 to the 0, my answer will be 1. So this sums up the laws of exponents, meaning that the sums that we'll be dealing with next, we will be using these laws. So if you're struggling with the laws of exponents, you'll have to go back to your grade 10 and also your grade 11. You'll have to go back just to recap, because the following sums that you'll be solving, Here is our first sum under exponents. The instruction is to simplify without the use of a calculator. So let's attempt. We have a 2 to the n plus 3 times a 3 to the n plus 2. So since we have a 6 underneath, which is to the n plus 1, let's try to express a 6 in terms of a 3 and 2. So I can just write what's on the top as it is, n plus a 2. Then underneath, I change my 6 to be a 3 times a 2 to the n plus 1. Then I go on to write this as it is again, 3n plus a 2. Then for this denominator, we'll have to use the law, the a, b to the n law, which means this n is for both the exponent of a and b, which this will give us an a to the n times b to the n. So we'll take our 3 to the n plus 1 times a 2 to the n plus 1. Then our next step, we can use our law that states that if you are dividing things of the same base, the a to the m and a to the n, dividing things of the same base, you'll have to subtract their exponents. You take one base and subtract their exponent. Now, in this instance, we have a 2 to the n plus 3 and this 3 to the n plus 2. And we have a 2 as well this side. So these are of the same base. So we can go on to express our 2 in the form of 2n plus a 3. Then I'm dividing things of the same base. I subtract the exponents. I take my n to the top. It will be a minus n. I take my 1 to the top. The sign will change to be a minus 1. And then let me just take this down as it is before we get to change the 3 as well. 3 to the n plus 2. Underneath, I now have a 3 to the n plus 1, of which from here, I'll now remove my fraction. And firstly, let's deal with this. N minus n, they are gone. Then we remain with a 3 minus 1. So we now have a 2 to the 3 minus 1 is a 2 to the 2. Then we go on to apply the very same law when it comes to these. For 3, we are dividing things of the same base. We have to subtract the exponents. At the top, we have a 3 to the n plus 2. We take this n to the top, the sign will change to be a minus n. We take this one to the top, the sign will change. It will become a minus 1. So we now have a 4 times n minus n, they are gone. Then a 2 minus 1, it's a 1. So it's 3 to the 1. Therefore, we have a 4 times 3, which gives us a 12. Yeah, so our answer for this sum is a 12. We'll go on to do our second sum. This is our second sum, where we are given a 4 to the n plus 1 times a 8 to the 2n all over a 16 to the 2n minus 1. Mark allocation is 5. Still the same instruction, simplify without the use of a calculator. Let's go on to solve the sum. So, for this given sum, we can express our base as 1 for all of these given bases. So we can just express a 4 to be a 2 to the 2, which is a 4, then n plus 1. We go on to our 8, which you can write as a 2 to the 3 to the 2n. Underneath, we go on to our 16, which is a 2 to the 4 to the 2n minus 1. Then from here, we'll apply the law, the a, b to the n law, where our a is to the n, also b to the n. This exponent outside is to multiply the exponent of a and the exponent of b. So when we have a 2 to the 2, these two will have to multiply. We'll have these 2, then 2 times n, which is 2n, 2 times 1, which is a plus 2. Then we have a 2 to the 3. Outside we have a 2n. So this will be our 2, then 3 times a 2n, which will give us a 6n. Then now we go underneath, we have a 2 to the 4, 2n minus 1. So this 4 will have to multiply 2n and also multiply negative 1. So 4 times 2n, we get an 8n. Then 4 times the negative 1, we get a minus 4. So we now have one base, which is the base of 2, base of 2, base of 2, even here on our denominator. Then we go on to apply our law at the top that states that multiplying things of the same base, we'll have to add exponents. So at the top, I'll have something like a 2 to the 2n plus a 2. Multiplying things of the same base, I add exponents. So I took one base, I'll have to say now it's a plus 6n all over. Let's not jump any steps. 8n minus 4. So at the top, we applied the law that states that multiplying things of the same base, you'll take one base, then add the exponents. That's why there's this plus 6. Then now, we are now dividing things of the same base. But before we go on to solve that, let's go further to simplify the top part, where we have the like terms, which is 2n plus 6n. We'll get our 2 to the 8n plus a 2 all over a 2 to the 8n minus a 4. Now we are dividing things of the same base, which the law states that if you are dividing things of the same base, you'll have to take one base, then subtract the exponents. So in this instance as well, we'll do the same. We'll take one base, which of the top part we have an 8n plus a 2. We take this up, the sign will change of an 8n to be a minus 8n. We take 4 up as well, the sign will change to be a plus 4. Then from here, we have the like terms, 8n minus 8n. They are gone. Then now we have a 2 plus a 4, which will give us a 6. So a 2 to the 6 will give us a 64. So our answer for this sum is 64. We'll now go on to our third sum. Given a 3 to the x plus 3 minus a 3 to the x plus 1 all over a 3 to the x plus 1. So on this sum we are having a minus, meaning that we can't just cancel out. At most, whenever you are having a plus or a minus, we'll have to take out a common factor. So let's just solve this sum. Instruction is to simplify without the use of a calculator, and the mark allocation for this sum is 4. So we break this down, a 3 to the x plus 3. Since we are seeing that the exponents are adding, it means that we had the same base. We are multiplying things of the same base. So this was a 3 to the x times a 3 to the 3 minus a 3 to the x times a 3 to the 1 all over a 3 to the x times a 3 to the 1. Now, from here, we will then take out a common factor at the top. We are seeing that we have a 3 to the x. Also, this side we have a 3 to the x. So if I am to take out a 3 to the x here, I'll take out my 3 to the x. I remain with a 3 to the 3. I take out a 3 to the x, I'll remain with a 3 to the 1. Underneath is 3 to the x times a 3 to the 1. Then we simplify what's in the bracket. We then have a 3 to the x, which is a 3 to the 3. We get a 27 minus a 3 all over a 3 to the x times a 3 to the 1. A 27 minus a 3 will get a 24 all over a 3 to the x times a 3 to the 1. Then a 3 to the x and a 3 to the x, they'll cancel out. Then I remain with a 24 all over 3, which gives us an 8. So our answer for this sum is an 8. We'll go on to solve the next one. This is our fourth sum, which is 5 times 2 to the x plus 1 minus a 2 to the x all over a 2 to the x minus 1. So instruction is still the same, simplify without the use of a calculator, and the mark allocation for this sum is 4 marks. So let's just solve the sum. Let's break this down. We are seeing that we have an x plus 1, meaning that the exponents are adding, so we are multiplying things of the same base. So we have a 5 times 2 to the x times a 2 to the 1 minus a 2 to the x all over a 2 to the x times a 2 to the negative 1. From here, before we take out a common factor at the top, let's firstly deal with this 2 to the negative 1. So what's at the top remains. It's 2 to the x times a 2 to the 1 minus a 2 to the x all over a 2 to the x. For this one, we'll change it to be our 1 all over 2, taken from the law that says an a to the minus 1 is the same as 1 all over a to the 1. Same goes if you had an a to the negative 2, it's the same as a 1 all over a to the 2. So that's what we did with this 2 to the negative 1, changing to be a 1 over 2. Then let's go back to the top where we are having a common factor of 2 to the x. So if I am to take out a 2 to the x as our common factor, I remain with a 5 times a 2. If I am to take out a 2 to the 1, I remain with a 1. So I've taken out my common factor. Underneath, I still remain with 2 to the x times a 1 over 2. Let's deal with the bracket. We have a 2 to the x. 5 times 2, we have it's a 10 minus 1 all over a 2 to the x times a 1 over 2. We then remain with a 9. So this is a 2 to the x, and 10 minus 1 is a 9 all over 2 to the x times a 1 over 2. So from here, these will cancel out. Then we remain with a 9 divided by a 1 over 2, which that will give us a 9 times a 2, which that our answer will be an 18. So our answer for this sum is 18.